It's linear interpolation. And interpolation is this. You can use this. This is kind of actually useful. You know, when am I ever going to use this in real life? Well, linear interpolation is useful because here's what it is. Let's say I have a graph in science of time and temperature. And I can plot at 1 o'clock, my temperature is here. At 2 o'clock, an hour later, my temperature is here. At 3 o'clock, my temperature is up here. Linear interpolation is this. It's got the prefix inter. You know science, your prefix is, what does inter mean? Interstate bridge.
It's like in the air.
Yeah, in between two states, right? They call the interstate bridge, the one that goes from Michigan to Wisconsin, Marinette to Menominee, the interstate bridge, because it goes between two states. Well, interpolation goes between 2 points. And linear interpolation uses the line between these two to predict values in between there. That's interpolation. It uses a line that goes between these 2 points to predict values in between there. Does that make sense? There's also one called extrapolation, extra. What's the prefix extra mean? If you're in an extracurricular activity, what is an extracurricular activity? That's like sports, right?
Yeah.
It's beyond the regular school day, outside of. Well, if you use the process of extrapolation, that uses the values that you have here to predict some that are beyond your graph. And extrapolation usually is not as accurate because you only have one endpoint. You don't have any other points beyond to help you predict. With interpolation, you've got a beginning, one on each side, I should say, one on each side. Does that make sense? So today we're going to use interpolation. We're going to use 2 endpoints to predict a value in the middle. We're going to use interpolation, 2 endpoints to predict something in between. So there's a chart in the book on 391, and I wrote it over here so we could look at it together. It's a chart of year 1910, 1920, 1930, and the population of the United States in that year in millions. So in 1920, the population was 106 million. In 1940, it was 132 million. In 1970, 203 million, and so on. Well, what happens if I want to know the population in 1953? I don't have 53, but I'm going to use values on either side. So would you agree that 1953 is somewhere in there? So right off the bat, you could probably predict that in 1953, the population is going to be somewhere between 151 million and 179 million. Would you agree? Well, what I like to do, if you want to get it right, I like to write in 1950, the population was 151 million. In 1960, the population was 179 million. And I want to know, what was the population in 1953? What was the population? I don't know. That's what we have to find. And what we're going to do is look at the change. The change here, the change here. What's the change between 1950 and 1953? Isn't that 3 years? What's the change here between 1950 and 1960? That's 10 years. On the other side, what's the change here? DK, I don't know. We can't tell what the change is because we don't know what P is. What's the change between here and here? Subtract the two. And I believe if you subtract 179, take away 151, you get 28, don't you? All you're going to do is set yourself up a little proportion. Little over big, little over big. Little over big, 3 over 10 equals little over big, C over 28. And you know how to solve that, right? Right? What do you do?
Cross multiply.
Cross multiply. So I have 10C equals, 2, 4, carry the 2, 6, 7, 8, 84, I think. Does that seem reasonable? Divide by 10, divide by 10, and I get C equals 8.4. Is that my answer? Remember, we want to know what was the population in 1953. What we just found was the change here. How am I going to figure out the population? Right, you're going to add it. You're going to take 151 and you're going to add 8.4. What does that come out to be?
159.
So what was the population approximately? Approximately 159 million. 159.4 million, but approximately 159. Does that make sense? Does that make sense? Anybody with a question on that one? What if I want to go the other way? I want to know what year was the population 140 million? Well, if you look over here, where does 140 million go in? About right here, I think, right? That's going to be somewhere between 1940 and 1950. So if I were you, I would write 1940, 1950. What was it in 1940? 132 million. In 1950, it was 151 million. And I want to know, in what year was the population 140 million? Like that. So again, we're just going to go little big, little big. I don't know what that change is, right? But I know this change is 10. Over here, what's the change here? I believe 8. And this one? Is that 19? 151 take away 132? Yeah. 19. So we're going to go little over big, little over big. C over 10 equals 8 over 19, little over big. Cross multiply. Cross multiply. C times 19. 10 times 8. Divide by 19. Divide by 19. What is C? It's 4 point something. I don't really care about the point something. What'd you say, Bob?
4.2, we'll go.
4.2-ish? Well, the question is, in what year was the population 140? Well, if I start at 140 and I add 4, 1944? That's all it wants to know, is what year? 1940 plus 4? Somewhere in 1944. We don't care about the point something. In what year was the population 140 million? 1944. Does that make sense? Does that make sense? Are we having fun yet? Oh no. I hate it when I talk and they can't see. 1944. Anybody with questions on this one? I just have one more here. One more just for fun. This one is just a little bit different because look, this is the altitude compared with the density. It talks about the air. As you go up in an airplane, for instance, what happens to the density of the air? Well, look at here. What happens to the density? It gets less, right? The air is less dense as you go higher and higher in altitude. So these values are still getting bigger, the altitude, but the pressures are getting smaller. That doesn't really matter that much. You still do it the same way. So I want to know, for instance, what is the pressure at 600 meters? What is the pressure at 600? So that's going to be somewhere between these two, I think. So I'm going to write myself over here. I don't like it when it goes sideways like that. I've got 500, I've got 1,000, and I want to know what is it at 600. At 500, the pressure is 1.167. At 1,000, it's 1.112. And I want to know what's the pressure in between there. So again, we're just going to set up little over big, little over big. What's this little change? That's easy, 100, right? Subtract. What's the big change here? 500. 1,000 take away 500? 500. What's this little change here? I don't know. What is it here? Let's see. 0.055, I think, right? Right? So again, we're just going to do little over big, 100 over 500 equals little over big. Cross multiply, that's not too hard. 500C equals, cross this way. When you multiply by 100, you just move the decimal over 2 places. Divide by 500. Divide by 500. I can't do that by myself today. Do you get this? I get 0.011. Do you get 0.011? Now, Remember over here when we got this value, we added it? When we got this value here, we added it. That's because the values were getting bigger. Well, over here, if the pressures are getting smaller, we subtract. Instead of adding it, we're going to subtract. So the change right here, it's going to be 1.167. Take away this value, 0.011. So what do I get? 651 kilograms per cubic meter? Does that seem reasonable? Is that somewhere in here? Is that value between 1.167 and 1.112? I think so. Does that seem reasonable? Does it? I think. Does it? That's it. Do you have questions? Anyone? Anyone? I'm on page 394. I'm on page 394.